All right, let's take a look now at example B. What would y'all like to do? Do you want to graph it first or do the algebra and then see if it matches up with the graph later? Graph first? Okay, let's go over to the graph. Kevin, sit up here. It's like 4 times already. Let's go to our graph. 4x plus 20 is the numerator. Four x plus 20 is the numerator, and the denominator is x squared plus 10x plus 25? All right, so here's our graph that we're going to be working with this time. Okay, so as we start working through this, we'll compare it to the graph as we go. Let's have you start walking me through how to find these values. How will you get your domain here? Donna, do you remember, how do we find our domain? Yeah, we'll have to do the x method because what we're looking for is where the denominator is equal to 0. You're not allowed to divide by 0, so that's where the domain will break. So we need to do an x method to factor this. So again, here's my a, b, and c. So on my x method, what would y'all put in the numerator here? I should say numerator, the top of the x. 25, I agree totally, 25. And now the bottom is 10. Moises, can you think of any numbers that multiplies to be 25 but adds to be 10? 5 and 5. So it's not 1 and 25, it's 5 and 5? Totally agree. So when I factor this, this is called standard form. I'm now going to write it in factored form here. I will have an x plus 5 and another x plus 5. Do I need to write x plus 5 twice? What's a way we could shorten it?
X plus 5
Squared. Perfect. X plus 5 squared. We have 2 of those. So what does that mean x cannot equal in the domain? Positive 5, negative 5. Negative. You would set this equal to, say this cannot equal 0. You'd have to add the 5 added across, so it's negative 5. It cannot equal negative 5. What can it equal? Everything else. Okay, in the numerator. Oh, nope, sorry, going too fast. To find out, let's talk about negative 5. Is it going to be a whole or a vertical asymptote? Well, we can see from here what it'll be, but if you did not know, you would need to, at this point, factor the numerator. This is not a trinomial. It's a binomial. This will be easier to factor. Is there a GCF here? Yeah, 4. I'm going to factor by GCF. If I divide out the 4, what's 4x divided by 4? X. And now what's 20 divided by 4? 5. Ooh, this is tricky. Maybe I shouldn't have written this as a squared. I'm going to edit this. X plus 5. Now, what can I do here? I can cancel, which makes you think that's removable. However, there's still a plus 5 left over. So on a whole and vertical asymptote, the whole is kind of like more powerful. It's like it'll trump it. And since there's still a plus 5 remaining, I still cannot be negative 5, even after I cancel it. So we're going to have x cannot equal negative 5 as a vertical asymptote or an infinite discontinuity, not as a whole. Since, just so you're clear, there's no whole, since x plus 5 still remains in the denominator. So even after we simplified, there's still an x plus 5, and that's why we don't have a whole. So let's go to our graph, and if you're adding like a quick sketch, you should have a vertical line at negative 5. 1, 2, 3, 4, 5. A vertical line at negative 5 to represent that vertical asymptote. Now that I do that, I go to horizontal asymptotes. Jesse, do you remember how to find a horizontal asymptote? Edwin, do you remember how to find a horizontal asymptote? Okay, well, I'll just jump in. It has to do with the powers. You compare powers. Are my powers bigger on the top, bigger on the bottom, or are the exponents the same? They're bigger on the bottom. That's an exponent of 1. This is exponent of 2. I'm bigger on bottom. The rule is Bobo. If it's bigger on bottom. Bigger on bottom, this O stands for y equals 0. So I'm going to add in a horizontal asymptote at 0. Which means my graph, though it cuts off, would be approaching that asymptote this way. Intercepts. Lorena, do you remember how to find an intercept? The y-intercept in particular? No? Okay, so I'll do some more practice until we get this down. You're going to plug in a 0. That's what you do. You plug in 0. So I want to use standard form just because I can see this will, plugging in 0 and all those first locations will cancel out. Or just paused on me. Let me try this. I have to try using a mouse here. So what will happen is this 4 times 0 cancels out, and so it'll just be 20 over. That's 0, 0, 25. It'll be 20 divided by 25. Could we reduce that? Yeah, what does that reduce to become? 4 over 5. That's correct. 4 divided by 5. And we've already had that once today. What is that as a decimal? Yeah, 0.8. My board's back. All right, 0.8. So I'm going to come over here and add that point in. That point right there is 0, 0.8. And now the 0. You solve the numerator equal to 0. I'm down to just 4 there. If I were to rewrite this one more time, I'm down to the equation 4 over x plus 5. Can 4 ever equal 0? No. So you don't have any zeros. And so that would be the appropriate graph there. Well, darn. Okay. And so finally, goodness, there we go. Let's do some limits. What happens as we go to the left? Does this graph rise without bound? Does it fall without bound? Or does it appear to get flat? Flat. It's approaching a horizontal asymptote. What's that asymptote? 0. Gets flat with 0. What about as we go to the right? Does it fall without bound, rise without bound, or does it appear to get flat? Flat. And so it's approaching the horizontal asymptote. 0 as well. Okay, what about, we have a break here at -5. Let's look at the left side and right side of -5. On the left side, what happens on the left side of this graph? It falls. -infinity. What happens on the right side? It rises. Are those the same? They're not the same? Since they're not the same, the limit at -5 would not exist. There's no other break, so I don't have to use this limit. I'm going to do it right here. This -5 does not exist because, I'm going to just erase that out of there. Or how about I just cover it up? These would not exist because these two are not equal. So the limit at -5 would not exist. All right, I'm going to roll one more time through, and then I'm going to let you see what we can do on the practice problems at the end. So I'm going to do one more with you, and then we're going to see what you can do at the end here. Okay, what would you do first here? Define domain. Well, let's find what x cannot be. Do I need to do x method for this binomial? Or can I do GCF? Do we have any GCFs? 2x. And, okay, so what's 2x squared divided by 2x? X. 2x squared divided by 2x is x plus, now 4x divided by 2x. 2. Good job, Jade and Jacoby. Heard you both. Good job there. Okay, there's that. So what can x not equal? You said we cannot equal 0. What about this here? We haven't done this yet. If 2x cannot equal 0?
0.
I'm doing 0 product property here. Is that 2 or 0? 0. So we cannot equal 0. That's one value we cannot equal. What about inside?
-2.
-2. So there's two values we cannot equal. What can we equal?
Everything else.
Anything else. Now let's find out if they're wholes, vertical asymptotes, or some combination. This I need an x method. So I have an a, b, and a c. What's a times c? -4, and my b? Okay, the factors of 4 were 1 and 4 and 2 and 2.
1, 4.
Which one can somehow combine for a 3? 1 and 4. Now let's figure out the negatives. So remember the options are you can have a negative positive, a positive negative, positive positive, or negative negative. Which way gives us a -3? -4. 1 minus 4 is -3. Good. We split the a terms power, so it should become x minus, plus 1 and x minus 4. Can I cancel anything? If you can't cancel, what does that mean? Holes or vertical asymptotes? They're going to be vertical asymptotes, so we have no holes. The vertical asymptotes, we will have 2. We will have them at 0 and at -2. Both these values, I'll do it in order this time, -2, comma, 0, from left to right. Sorry I didn't graph first. We're just going to do algebra first this time, then we'll compare the graph after. Horizontal asymptote. Look at your exponents. Bigger on top, bigger on bottom, or are the exponents the same? Exponents are the same, so you would go off you would divide your coefficients. If the exponents are the same, you divide the coefficients. So it would be y equals 1 divided by 2. So you can leave it like that, or you can say it's 0.5, whichever you prefer. 1/2 or 0.5. The y-intercepts. How do we find a y-intercept again? Okay, so when we plug in a 0, I'm going to use -4, and the denominator I plug in 0, what am I left with? Nothing. Everything, that's a 0. 2 times 0 squared is 0, plus 4 times 0, that's 0. Can I do that? No. So I don't want AP to count off. So we're going to take away that equal sign. We're going to say F0 is undefined. Finally, the zeros. We look back at the numerator. To find the zeros, you say, where does the numerator actually equal 0? -1, +4. Good. -1 and +4. Okay, now I'm going to graph it, and we'll see if our values match up correctly. So our equation was x squared minus 3x, not plus 4, it was a minus 4, wasn't it? Is that it? X squared minus 3x minus 4?
Yes.
Okay, and the denominator? 2x squared plus 4x. No constant. Look at that graph. All right, there we go. So the first thing, the domain, we said it has two breaks, and those breaks we defined as vertical asymptotes at -2 and 0. Does that appear to be accurate?
Yes.
Yeah. What's another name for a vertical asymptote? It's a type of discontinuity. What could they call that? Would it be infinite, jump, or removable?
Removable.
Ooh, nope. The graph's going to
Jump.
infinity, so we call that infinite discontinuities. So this one's x equals -2. This one's x equals 0. We have a horizontal asymptote at 1/2. It's hard to see where 1/2 is, but it'll be approximately right there. Whoops, wrong line. Approximately right here is 1/2. And that does appear to be accurate. Y equals 1/2 for the horizontal asymptote. We do not have a y-intercept. That looks pretty accurate. No y-intercept. But we do have two zeros. We have a 0 at -1. That point there is at -1, comma 0. And then I also have a 0 right here at 4. So our graph looks pretty good. All right, let's fill in our limits. What happens as this function goes to the left? Does it rise without bound? Does it fall without bound? Or does it appear to be getting flat on the with a horizontal asymptote? Edwin, what do you think? As we go left, does this graph appear to rise without bound, fall, or get really flat? Flat. And what's our asymptote that's getting flat with? What's the y value there? 1/2. Yep, 1/2. Okay, what happens as we go to the right? As we go to the right, does this rise without bound? Does it fall without bound? Or does it start getting really flat with a horizontal asymptote? Flat with a horizontal asymptote. So it's approaching 1/2. Very good. We had two breaks in the domain. We'll first look at -2. So this -2 minus and a -2 plus. What is happening as we approach -2 from the left side? It's rising to infinity. What happens as we look at the -2 from the right side? So here's -2, but from the right side. It's rising or falling? Falling this time. Are they equal to each other? No. So the limit would not exist at -2. This limit at -2 does not exist. Without the plus and the minus, does not exist. Oh man, trying to sneak that in there. Okay, now let's look at 0. As we approach 0 from the left and as we approach 0 from the right. Here is 0. What happens as we approach 0 from the left? Rises. Good. What happens as we approach 0 from the right side? It falls. Are they the same or different? Okay, if they're different, then the limit at 0 exists or does not exist? Does not exist. Very good.